Hello, my name is Bisarul Hassan, and I am demonstrating assignment 3 for Big Data Technologies. So we were giving Yellow Taxi Trip Records dataset for the month of January, March, and June, which had these variables: vendor ID, pickup data, date time, drop off time, passenger count, trip distance, location, rate code ID, and payment type, fare amount, and all the other variables as mentioned in this data dictionary. So let's jump into the Jupyter notebook to see our analysis. So basically in the first part, I have loaded the data set all for all the 3 months using Parquet data file. Uh, First in data frame 1, then March data in data frame 3, and the June data in data frame 6. We can see the columns and rows of all the 3 data sets. So these are all the same columns as we discussed in the data dictionary um, with their first 5 rows. Going onwards, we can see all the 3 data sets have same number of rows and 19 columns. Going further, we use data dictionary to understand columns. So um, most of our data columns are of float data type. They are numerical, as well as these ones are also numerical. Just one store and forward flag is of object type, that is string type. Uh, and then these two are date time formats. Going further, we described our data set, which showed count, mean, minimum, and standard deviation, etc. We further analyzed all the 3 data set in different um, cells. So we looked at data frame 1, vendor ID, payment type, airport fee, and we can see the values for these. Going onward, we can see airport fee has minus 1.25 and 3,607 rows has this value, which doesn't seem right. Similarly, these are the passenger counts for trips, mostly lie around 1 passenger per trip and then 2 passengers. Going onwards, we have fare amount. Fare amount is also in negative values. That's also problematic. Um, we similarly extracted these for the MART data, in which we can see there is one more vendor introduced. Um, Other than this, payment type is also increased. Similarly, for data, June data, we can see the same thing. Um, Going onwards, we can see in part 2, um, we compared all the 3 months data, and we can see that the March month has more trip counts as compared to June and January. June comes on second. These are the counts. March had 3.4 million. Um, Similarly, we found the trend for trip distance. So June was the month where the average trip distance in mile was the most, being 4.3 miles, and then March 3.9 miles. Going onwards, we also seen the fare amount for different months. So it's the fare amount for the month of June is 19.98. On second number is March and then January, which shows the similar trend as the distance traveled. So we can see they are correlated. Further on, we explored the data and pre-processed it. So we checked for the missing values. These are the columns which had missing values, and um, I think these all missing values are in the same rows. So we can maybe drop it or we can impute it. The data is around 5 to 10% missing values. So I thought to impute it. So looking at the missing value columns, passenger count, um, and all the other values, we can see that the data is more around one passenger and then two passengers. So we used mod, most common value, to for imputation for all of these, as most of the values are in one category. Similarly for this, except for one thing, which is airport fee 1 to 5 trips, which had missing values, and um, yeah, which had same missing values, and we imputed using location. So as mentioned here, 1.25 for pickup only at these airports. So I took the location of these airports, extracted these airports location where the value is 1.25, and similarly the missing values where these locations, uh, for the missing values for these locations, I have imputed 1.25, and the rest is filled with 0. I created an empty rows mask and then imputed in that way. We can see all the data is now has doesn't has any missing value. In part two, we identified the noisy values. So passenger count, um, I set the logic as where passenger count is equal to or less than 0. That's I think noisy, because taxi trip would not have a 0 passenger count, as long as it's not providing some delivery service. So these are the erroneous values. Also for airport fee, I think it could not be negative. So yeah. Also for total amounts, which was less than equal to 0, these were the values. I think to read on this. Yep. So for congestion surcharge, it was similar, and these values are so less, we can um, drop these rows to remove the error. I plotted the distribution for just passenger counts. We can do this for the other variables as well. So passenger count, airport fee, and total amount, these are the columns which had erroneous values. I think minus 1.25 shouldn't be there. Other than this, we took the correlation matrix of the whole data frame by dropping the string value, just taking the numerical columns and then taking the correlation, which showed that the total amount and pair amount had the most strong linear relationship, and then followed by improvement surcharge and MTA tax. Um, we created new features in which I created a feature named as rush hour is rush hour. Um, so wherever I set a threshold of 1.5, um, sorry, one, I've set it as 1.5, yes, 150, yeah. as threshold for rush hour, and then above that, the hours which has trips more than that, I set it as rush hours. So based on that, we set is rush hour or not. And this is a verification for our new feature, which is added over here. We checked if it's giving, so it's not giving it rush hour value 0 and 1. We can give it true and false as well. Going onwards, we calculated the distance in which I had like PU location ID pickup and drop off locations. Instead, if we had latitude, longitude, we can calculate the complexity of the trip as well, in which straight line distance versus actual distance can be used to calculate it. Furthermore, pickup frequency. So I calculated the pickup and drop off frequency. So these locations had most pickup frequency, and these locations had most drop off location frequency. Further, we did data analysis in which we saw vendor ID2 had the most trip counts, and these were the peak hours in ascending order. So in morning 7 to 2 um, is the time for peak hours, and 3 to um, 10 is evening peak hours range. In part 3, we calculated the average distance on weekdays is 4.1 miles, and weekends is 3.7 miles. Similarly, average number of passengers on weekdays is 1.43, and weekends 1.34. So basically, average number of passengers stays the same for both of the days. Correlation between fare amount and tip was moderate. It was not so strong. Also, this is very weak relationship between fare amount and number of passengers. So we concluded with all of our summaries as uh, I discussed earlier. This is our summary. Missing data gave me a few challenges, defining rush hour and making sure the data quality is not compromised. We can do statistical modeling to see which variables are good predictors of response variables, and do location analysis, customer segmentation, and driver analysis. That's the end. Thank you for watching.